I'm Mohammed Bentires Alj. People call me Momo. My lab is at Friedrich Miescher Institute in Basel, and we focus on the cellular and molecular mechanisms regulating normal and neoplastic breast stem cells, resistance to targeted therapy, and metastasis. I'm pleased to welcome you to conversations with key figures in mammary gland biology and breast cancer.
I'm Zena Werb. I'm a professor and vice chair of the Department of Anatomy at the University of California, San Francisco. And I work on mammary development and on breast cancer, but I'm also interested in a larger context in the cellular microenvironment, both normal and tumor, and not necessarily only in the breast.
Okay, thank you. So Zena, you were born in Germany and then moved to Canada, where you obtained your bachelor in biochemistry and physiology at the University of Toronto. Then you went to the US and obtained a PhD in cell biology at Rockefeller, New York, in 1971.
Yes.
And several papers from your PhD were on cholesterol metabolism in macrophages. Can you tell us more about this work on inflammatory cells?
So I was interested in the fact that atherosclerotic plaques had lipid in it, and a lot of the lipid was in macrophages. And so the question was, how did those cells end up with the lipid? What lipid was there? And so I started to do experiments in Zanvil Cohn's lab. He was the macrophage expert and had set up many types of cell culture models, and so asking what happened if you gave those cells sources of lipid. So we could see that they would take up cholesterol and store it, and then also excrete it. And you could do the same looking at cholesterol esters, and from that I actually started to go to the next step. What about other cells like fibroblasts? And looked like they had this kind of uptake and loss. And the experiments that I didn't get to do because I couldn't get hold of the lipoproteins. In those days, people isolated lipoproteins mostly on gradients and so on, and I tried to get some from people who were doing that down at NYU, but the real problem was they didn't want to talk to a female graduate student. This business about women in science was a real problem during my thesis with several people I had to interact with, not with my advisor, but other people, and that whole field of that went into cardiology and so on. I think even to this day is a little testosterone driven. Anyway, the experiment, I did all the lipid experiments. I wanted to do the protein experiments, and the protein experiments, which I never got to, would have discovered the LDL receptor. And in fact, Joe Goldstein now has asked me, how come I didn't do those experiments? So I told him.
So then you went to England for a postdoc at Strange Ways Research Lab in Cambridge, working on protein chemistry.
Yeah, so I had learned a lot about cell biology, and I'd learned a lot about lipids, and I wanted to get a much stronger knowledge of proteins, because when I went to graduate school at Rockefeller, I had originally wanted to do X-ray crystallography. I was very interested in these kind of biophysical thing. So I thought, well, now on a more biologic level, I wanted to learn about proteins, and there were some good scientists there, and so I ended up going to Strange Ways, which had a strong reputation both in proteases but also in development, because Damon Erfel, who had been the previous director for many years, was a really wonderful developmental biologist, particularly in cartilage and early development. So it seemed like a good place to go, and so I went there. And after 2 years, I actually applied for an MRC grant, and with some complications, it got funded, and I was actually offered a position, and I could have stayed even permanently, but I decided I didn't want to be in England any longer.
So what was your postdoc about, the topic of your
So
research?
I started off being interested in lysosomes, but the postdoc who worked next to me was working on matrix metalloproteinases, and so we got talking, and I said, I wonder if the cells I've been playing with to look at lysosomal enzymes and so on might be making one of these MMP, what are now called MMPs, collagenase, and lo and behold, they were. And that, of course, was the first discovery that, other than in neutrophils, of a cellular source, and that just opened up that whole area. So I ended up doing mostly analysis of the collagenase being made antibodies, tried to understand the regulation, and then went on to show that a couple of these proteases were actually being made by macrophages, including the macrophage metalloelastase, as it's now called, and a collagenase. And so, the topic kept growing and growing.
Oh, wow. So you joined UCSF in 1975 as assistant adjunct professor.
Yes.
But before talking about your academic appointments and your scientific career, can you tell us a bit about your personal history, birthplace, childhood?
Well, I was born in Europe, as many people were, as part of the, it was the Second World War, and my parents were Jewish, and I'm lucky to be alive, and so I have no direct content, and in terms of Germany, I'm just lucky that, having been born, that I actually survived. When the war ended, my parents had been separated, and I went with my mother back to Poland, to Kielce, and what happened there, I don't remember this, but this is that they started to be pogroms, and it took nearly 2 years before my mother made contact with my father. Everybody was sending letters all over the place, looking for, and a newspaper, and they made contact, and he said my father was in Italy, because he had actually ended up in Italy with a whole bunch of other people who had been from Russia, as it turned out. And my mother said, don't come, we'll come to you. And so it took about 6 months to go from Poland, through Czechoslovakia, through Austria, then over the Alps through the Brenner Pass. And in fact, there were groups that were being taken over the Brenner Pass every night, and they wouldn't take us because I was a child, a 2-year-old. And so my father arranged for a private person to take us. And we actually were turned back twice and made it on the third time. And, into Italy, and then, onto train. And my father would go and meet the train every day. And the day he didn't meet it, of course, we came.
You're alive.
So once we were there, it was a question of what to do. We were staying in a place called Adriatica. It had been a military camp just outside of Milan, and then it was a question where to go. So the possibilities were to go to Israel, and my father was involved to some extent, getting boats for people who were then, part of the exodus, into Palestine in those days. The other alternative was South America, either Brazil or mostly Brazil rather than Argentina. And the third possibility was Canada. And so we ended up going to Canada because my father had, in Canada, his oldest brother, who had actually left for Canada before my father was born. My father was the youngest of 14 children. And so he had been in Canada since 1913. And then he had helped another brother and a sister
Yes.
go to Canada. So there was a family. And my mother had an aunt and relatives also in Canada. And so we ended up being sponsored by my uncle. And
So you went to
ended up in
Montreal or Toronto?
So we initially, landed in Halifax on a boat, and I actually remember a little of that boat trip because it was in early May, and it was one of the worst
Oh, yes.
crossings of the North Atlantic. It was very rough, and I remember being
yes.
seasick.
Oh, wow.
Anyway, so we landed in Halifax, took the train to Toronto where my mother had relatives, stayed there for, I don't know, a week or so, and then went to Saskatchewan because my uncle lived in North Battleford, Saskatchewan. And so he put us on a farm. Now, my mother grew up in Warsaw, and my father had been, he grew up in a smaller town, but he then was in the city. And here you are on a farm with the nearest neighbor about 3 miles away.
Oh, wow.
And we had telephone, but no electricity. And so, we shipped cream because you could put it down in the well, you separate it. And we stayed there a year. I think, my parents couldn't stand it. And then went to Toronto. And it was economically a very bad time in Canada. The economy was not good. My father had to work in a lumber yard and things like that. And then he went into business. So I grew up partly in Toronto and then partly after that on a farm because having started doing farming, my father decided, in the bad economic situation that was where to, what to do. And so for most of my childhood and, through grade school, which was about a mile away, a one-room schoolhouse with 8 grades, then to a high school, which was about 10 miles away with a bus that came and picked you up and took about an hour. And that high school had 200 children the year I started and 300 the year I finished. There were 10 people in my graduating class. And so then I went to Toronto, the University of Toronto. And, that's when I really saw things very different. And it was very exciting when I finished to apply to graduate schools and get on a plane to go be interviewed in New York.
Oh, it's fantastic. But what made you go into science and not art or music or something else?
At the end of high school, the 2 areas I was interested in were science, particularly, sort of math, physics kind of things, and also law. So it was a question of whether I wanted to become a lawyer or a scientist. My father's background was in physics and math, and he had done some teaching of that. And so, I learned Newton's laws when I was 4 years old. So, that was something...
almost natural.
Yeah, I may have grown up on a farm, but we were a very unusual farming family, at least for Canada. We listened to the Metropolitan Opera on the radio on Saturdays and things like that. So it wasn't the usual kind of family. It was, this is what you had to do. But, the idea was that we were going to be educated.
Oh, that's fantastic. So who were your role models back then, if any?
The role models before university were mostly just a concept. I didn't see myself being one of my high school teachers but it was a concept that my parents actually put into my mind, even though my mother just had a little bit of gymnasium study and so on because, her family couldn't afford it. But, the idea that anything was possible was what was so important. And so it was this idea that, the wonder of Canada was that you could get education.
Yes.
as I said, my interest then was both science and law, and then I decided I really liked science better, and when I started university, I was sort of interested, as I said, in physics and so on. I decided I wasn't a good enough mathematician to be an astrophysicist. It wasn't that I was bad, I was just not gifted as a mathematician. And so I thought, well, geophysics. And so the first year I took general science, so you took a little of everything. And then in the summer there was a field course to the Rockies to study essentially earthquakes. They wouldn't let me go on it because I was female.
Wow, so already there, yeah.
I did get a job in a lab, though, from the head of the geology department. Looking at the age of various rocks from the Precambrian Shield. But I decided that there wasn't a future in geology or geophysics for women, and decided to go into biochemistry instead. And that's but the thing is that I'm telling you that there were a few occasions in which I had these barriers because I was female, yet I dealt with them and moved on. And even though they were issues and real at the time, the fact that you sort of say, well, what can I do instead, and move on. In all of these cases, what the alternative was much more successful than I would have been if I had continued in the other areas. So I think the take-home lesson from that is we make decisions for lots of reasons, and sometimes they're for negative reasons, but that doesn't mean that the outcome isn't the right one.
Yes. So then in 1973, you had your first academic appointment.
Well, that was that strange
way.
Well, because I had the postdoctoral fellowship, and then we got these MRC grants.
Yes.
And so I had a little bit more independence, but not fully independent, And the European system, the hair doctor professor is still over you. You do all the thinking, but they're still part of your papers.
Yes. But then you moved to Missouri, then to New Hampshire.
Oh, well, the Missouri was... Okay, well, so what had happened is after a year and a half more there, I decided I needed to go back to North America. And I looked at jobs in Canada, and it was a very bad time economically, and there wasn't a lot of support for science. And although I was offered a job, it wasn't the job that I wanted. It didn't have the potential to really develop. I mean, you could do research, you could do some teaching, but it didn't allow you to sort of develop your own ideas. And so I looked around, and I was offered a job actually in Seattle, and that was going to be everything that was going to, it sounded really perfect. And then I decided to spend several months traveling around the world before that. And when I got to Japan, to Tokyo, I went to the American Express office. That's how you got your mail in those days. And I had a Dear John or a Dear Zena letter that the position had fallen through. What I didn't know is it was a soft money position, and the grant didn't come through. And so I had been offered to go to Dartmouth medical school on a temporary basis for a year or two before that, and I turned it down, and now I took that up. But actually at the time that I took, before I actually moved, I started to look for other positions, and as it turned out, I was offered the position in California before I went to New Hampshire, but I decided that I would keep my promise to spend a year there, and meanwhile set up my lab.
Okay.
And so when I moved to California, I had a technician, I had a
So
lab
the lab was
assistant,
already.
I had equipment there. We had about a week's downtime.
So you still remember this moment when you started the lab?
Right.
Oh, that's.
And of course, at that point, I was still working in the lab with my own hands.
So you remember what kind of research projects you started
Well,
with?
I started working on more things on the proteases, on the MMPs, and chasing
Yeah.
those things out, and that lasted for several years. But then I started to get more interested in some of the biological questions.
Yes.
And so I went into two areas. One of the areas I went into was early development, because I figured if proteases were important, they had to be important for implantation.
Yes.
So I started to work on that problem. And these thinking about other projects or other potentially interesting areas, I realized that there were other developmental systems that could be interesting, and about that time I got to know Mina Bissell. It was actually a social interaction
Yes.
initially, because she was a friend of my first graduate student,
Okay.
who was a woman who had essentially gone back to do her PhD, even though she had a couple of
Yes.
kids and had worked for a number of years, so they knew each other. And then we started to talk and sort of said, oh, well,
Yes.
during mammary gland development, again, you had all this invasion
Yes.
and remodeling that particularly after lactation, and
Yes.
it would be worthwhile studying that. And we got a joint postdoc, Rabia Talhoub.
Yes.
And that was the beginning of a long and very fruitful
collaboration.
set of
And
collaborations.
friendship, I'm sure.
Yeah.
So we will come to Mina in a few. But UCSF has a reputation of good mentoring for junior faculty. Was it like this back in the 70s? And who were your mentors, if any?
So it wasn't organized in those days, and it was more sporadic. But the person who recruited me, Harvey Patt, was actually very good. The only problem is that he then developed lung cancer and died. And the people who followed him didn't have that. But the other person who was really my mentor was a woman, Dorothy Bainton. And so Dee had worked in neutrophils and so on, and I knew her name, and I had met her actually when I was still a graduate student at a Gordon conference.
Okay.
And, we'd run into each other from time to time. And she was the one who actually suggested I look at these jobs at UCSF,
Okay.
and remained my mentor for many years. She eventually became the chair of the Department of Pathology, and then she became the vice chancellor of the university. She now retired, but so she was in many ways my closest mentor.
What did she do that was appealing to you?
Well, I think what she did was really sort of encouraged me. We did some collaborations together, but it was really having someone who to some extent felt that you were special. The other mentor I had, who I think was much more of a mentor in the sense that she put me up for awards and so on, was Betty Hay, Elizabeth Hay. So again, I knew Betty only from meeting her at meetings, because she was chair of the department in, I guess what they were calling cell biology by then, at Harvard.
At Harvard, okay.
And, she always looked out for a lot of up-and-coming young women, and she, sponsored me for, awards, and, just all of this encouragement that it wasn't just that, you know, she said, "You're doing all right," and so on, but she was really like a patron for me in the scientific realm.
Yes.
And I think that makes a big difference.
Absolutely.
You know, where you have someone who is your, you know, it has you in mind and does, you know, make sure that you are being noticed.
Yes.
And I think that makes a big difference to people, because
Absolutely.
people who have, as I call them, patrons, often, you know, make it up much faster and into, you know, get better known than people who are equally talented scientifically, but no one points them out all the time. Other than that, I think I also learned that you had to be your own mentor. That is, that you had to evaluate yourself very critically and ask what it is that you need to do to make the next step. I mean, this is something I tell, you know, junior people, so on. They say, "Well, when should I start looking for a job or whatever?" I said, "Well, you know, the day you become a postdoc, you should think about what you need to get your next position. Because if you wait 3 years or 4 years, it's too late."
Absolutely.
Exactly. And so you had to, you know, I learned that I had to do that for myself as well. Whereas I think that I would tell people to push, you know, promotion or push things like that more. I didn't do that to, you know, at all, but because I had people who were on my side, that it happened to enough.
Yes. So, in your own lab, you continue to work on proteases.
And we still do.
Yeah, I know. And proteolysis was viewed as only a destruction process, and you discovered the relevance of proteolysis as a way of altering extracellular signaling. This was a real paradigm shift.
Yes, no.
How did you come to these conclusions? Can
Well,
you tell us historically?
Well, I think that the one thing that I've always done scientifically was not, you know, you make a hypothesis, but never to take my own hypotheses too seriously. You know, you use them as a way of formulating an experiment. But to look at the data, and the data do not lie. They tell you something. And what I learned to do was to really look to see what information the data were giving.
Yes.
You know, so that that became, you know, very obvious that when you did some of these things with the, you know, where you added a protease to a cell, you know, the cell changed shape. Well,
Yes.
you know, you could interpret it, oh, well, you just cleaved some of the adhesion molecules. But then the question is, well, but what's the consequence of that?
Inside.
How does that happen? What's happening in the cell?
Inside,
How important is that? And it's going away from the sort of expected answer, yes, you cleaved some adhesion molecule, to what the consequence of that is and what that means, and also whether it's physiologically relevant.
But how did the community, like when you submitted the first paper on this, how did they react? Because that was like kind of...
Well, you know, it's an interesting thing that some people feel that when they found something that's very different from what everybody else has been seeing, that it is not accepted. And I've never had that as a real issue, because I always tried to put it into a context of, you know, they were right, but this is, you know, the next step.
Yes.
And it's by actually trying to understand, you know, what other people were doing. That is, you know, that you could see that you were cleaving a molecule,
Sure.
and then sort of going the next step instead of, even though, you know, you're using new words,
Yes.
being very diplomatic, but realistic.
Yes.
About what was going on.
Mhm.
And I think that made a lot of difference. You know, I never tried to sort of put people's noses out of joint saying they were wrong. Because in in most cases, they weren't wrong.
Yeah.
They just didn't go to the next step. I mean, there were cases, of course, where people were wrong, which with the metalloproteinases, where all these companies wanted to see that it would cure cancer, and I actually said it wasn't going to because they weren't looking at their data critically enough,
Yeah.
or they had done the wrong experiments. In that case, again, there was nothing wrong with the data in the experiment. It was just the wrong experiment.
Yes. So your work on macrophages, secreted factors,
Mhm.
and proteases control of the
Mhm.
extracellular microenvironment yielded numerous important papers.
Mm.
But the first time you were an author on a paper with the mammary gland
Mhm.
was in 1991, if I'm
No,
correct.
it was before.
It was before?
I
Because
think it
this looked like your 86th paper, and in the title I found mammary gland. And it was the paper of Rabia,
Yeah, that was the
Temple.
first. That was the first paper
who
on
was,
the mammary
he was a
gland.
postdoc in Mina's lab. I
He
think.
was. It was a joint between the two
Okay,
labs.
and now he is professor at the American University of
Yeah.
Beirut.
So he applied to Mina, and I was the head of a training grant,
Okay.
and although he had been born in Lebanon, he had lived in the United States and actually was a U.S. citizen.
Okay.
So he qualified for being on the
Program.
training
Yeah.
grant. So I was paying him, and he was mostly over in that lab, but also in my lab. So benefit. So he was really between the two of us.
And that was the paper about the importance of proteases in mammary gland.
Yeah, and mammary
remodeling.
gland development. Yes,
And remodeling, yeah.
and remodeling, mostly in involution. Yes, and so again, sort of thinking where proteases were going to be important. It was sort of mammary gland, and of course involution.
Involution,
You had
yes,
to get rid of all
absolutely.
this stuff. So were proteases going to be important? And so that's how we started, and we kept going and
Right,
going.
Of course. So in 1992, you published another paper entitled Coordinated Expression of Extracellular Matrix Degrading Proteinases and their inhibitors regulates mammary epithelial function during involution.
Hmm.
So that was the study on involution. Do you remember what was the
Well, the question,
questions that you asked?
well,
at the
those
beginning?
questions in those days were quite important in that, the proteases had been discovered, and the inhibitors,
Yes,
the TIMs,
TIMs.
tissue inhibitors of metalloproteinases, had been discovered. And then the question was how you balance that. And what was quite interesting is that, immediately after you took pups away, you had proteases come on, but the inhibitors came on. And it's only after, a period of at least 24 hours that the balance now shifted towards the enzymes. So what physiologically is happening, you set up to break down the lactational system, but you want to make sure that you're not going to find your pups again and need to lactate.
Yeah.
So that makes biologic sense. But that actually was what was happening, is that the system immediately could turn on,
Yeah.
but it had a fail-safe that of being able to return to lactation.
Yes.
And so that was conceptually very important. And in a number of other papers, we were really quite interested in that balance. And it turns out that most important biology or biologic systems have a positive and a negative
Yes.
regulator. And that's because when you have the two, they balance each other out. And then it means that you only need small tweaks in either direction
Yeah.
to either turn something on or turn it way off. And that works, very, very well to be able to have small repairs, wound healing, angiogenesis. And in fact, angiogenesis is one of the areas where that kind of balance is really significant, because, you know, if you have half the amount of vascular endothelial growth factor, you're dead. And if you have twice the amount, you're dead. You know, so the system is so buffered, it can't take more than that kind of a change. But it's those little things, you know, maybe a 1% change would have an effect on, you know, put a blood vessel back right there.
After this paper followed numerous high-profile papers on one of them was mammary cancer related. Now it's cancer, it's not development. And this was a Cell paper, and the title, if I recall, was Stromal Proteinase MMP3 Promotes Mammary Carcinogenesis. I'm sure you remember this.
Yeah. Oh yeah.
paper.
No, so the question at that point was, so we could start to understand how some of these proteases might be working normally. But what was already very evident in the literature is that proteases were very high in cancer. And in fact, most of those proteases turned out not to be made by the tumor cells, although they could be made by tumor cells, particularly in culture. But in vivo, they were mostly being made by the stroma, the macrophages, and related cells, the vasculature itself, and the fibroblastic cells. So the question was, it's so high, what on earth is it doing? So we decided to make a transgenic mouse that overexpressed an active form of MMP3. And why MMP3? Well, it had interesting developmental regulation. That was one thing. And the second part was that I had discovered it and named it. It was stromalysin.
Yes.
And so, you know, it was, you know, the one that was sort of the closest to, you know, my sort of home. So we did that, and what we saw was that if you now look during development in those animals, during lactation, there was so much protease being made because it was being driven by a milk protein promoter, that it actually degraded a lot of the basement membrane around the lactational alveoli, acini in the mammary gland. And so that was a pretty striking observation. The other thing is that if you looked earlier, it looked like there was hyperplastic growth. In other words, right from the beginning, you got excess branching in the mammary gland, and then, as I said, the extracellular matrix breakdown was really clear, starting in late pregnancy, but particularly during lactation. Yeah. So, as we allowed some of the animals to get older, what we saw was, you know, you had excess branching, and then some of them started to progress to actually be, you know, hyperplastic, to have a lot of stroma. You know, so what we're seeing is a protease was actually stimulating the laying down of lots of collagen, you know, of giving you a fibrotic or desmoplastic response. And then within that, you now saw things that were even further progressed, sort of to sort of adenoma, and about 12% actually got adenocarcinoma. They were somewhat heterogeneous, but you know, the excess branching and the hyperplasias and the desmoplasia was pretty uniform. And then what we had done at the time was also cross them into animals that we had overexpressed TIMP1, which is an inhibitor of the MMP3, and that rescued it. And then we actually had because we had used the wrong promoter, you know, we didn't know what we were doing that well. We lost the expression. And when you didn't have the expression, I mean, it was almost, you know, the animals stopped having even the mild hyperplasias. So it was very clear what was going on.
And TIMP expression rescued most or all of the phenotype?
It rescued all of the phenotype.
All of them, yeah.
And so we now have some new insights as to what is going on. And, you know, I can tell you about that if you're interested, maybe a little bit later.
Okay, yeah. So, but then at the same time, at the same period, you also published studies with Doug Hanahan on MMPs and angiogenesis.
Mm-hmm.
It seems like you had a terrific environment at UCSF. Can you tell us about this period of time?
So UCSF has been wonderful for a long time. I mean, from the time, even before I got there, in that no one ever had a lot of space. You know, they, you know, even very successful scientists rarely had more room than, you know, 12 benches.
Yes.
In fact, that's kind of the standard. And so that means if you want to do something really new, you or different, you didn't hire in more people to do, but you collaborated with your neighbors. And to this day, you can see that the papers from UCSF very often have multiple scientists on them.
From UCSF.
Yes, and you know, that's been really part of our strength in that people really interact.
Yes.
And so that came about, that, you know, I was getting into cancer,
Mm-hmm.
and so then the question is, you know, what was going on? So the initial thing that happened was that we had done a knockout of MMP9,
Yes.
and it looked like the phenotype which we saw, which was mostly initially on bone development, that the conversion of cartilage to bone requires an avascular tissue to become vascular, and so it required vascularization. And so we collaborated with Gabrielle Bergers, who was in Doug Hanahan's lab at that time as a postdoc, to really get the angiogenesis part of that done well. And, you know, then that generated further collaborations with Doug's group, with both Lisa Cousins, who was a postdoc at the time, and also with Gabrielle Bergers. Both of those, of course,
So
have
Lisa
done
was
their...
postdoc with you?
Hmm?
Lisa
No,
was-
the
with
postdoc with Doug.
Uh-huh.
And so, you know, she got Lisa got interested in, you know, what was going on in the skin cancer model, and came down to me, and I said, "You've got all these mast cells and
Oh, yes, I remember this.
other inflammatory cells." She didn't know what on earth they were. You know, she's now one of the world experts in that area, but she didn't know what they. She said, "What's a mast cell?" So, you know, it was a big learning experience for her.
This was like around 2000.
Yeah.
I remember these papers. I was
Yeah.
starting my postdocs.
Yeah, so, you know, the interaction started, you know, in the late 90s,
Yes.
and, you know, when we
Papers,
started to,
yeah.
the papers started to be published then. And so, you know, we had this strong interaction with Doug and Doug's group as a result, and of course interactions with many other groups as well.